So hello everyone. In previous class we have discussed about this particular things. Derrick load calculation means how much amount of the load which is acting on the derrick, and that load is uh, hook load, fast line load, and the dead line load. Based on that load we have calculated Derrick load, right? And this was the final expression we have obtained in the previous class. If you haven't watched my previous lecture, go there and find the lecture. Right now we want to understand very important concept in a hosting system. That concept is basically related to the load distribution, means the force distribution, right? So what does it means by the force distribution or load distribution, whatever the things are, right? So if you go to the actual rig, that is, you can assume that this is your rig floor, right? And this rig floor having a four leg A, leg B, leg C, and leg D. We are just name it. You can name according to your comfort, right? So these leg will experiencing a some load, and that load is given by hook which is acting at the center, right? Fast line load and the dead line load. These are the three load which is acting on the derrick system, right? Hosting system, as we discussed earlier. So we need to identify the what could be the load on the leg, leg A, leg B, leg C, and leg D, right? So why we need to know this thing? The only reason behind it to know about this thing, because when you are applying some amount of load, right, and that load could exceed the strength of any of these leg, in that particular case what will happen, your all the rig system will going to collapse. So in that particular condition we are trying to find out that the is there any of these leg are experiencing a maximum load, and if any leg is experiencing maximum load, in that case how we are going to minimize this load to how we are going to minimize this load. So now this is the load distribution we want to study, right? In this case there are three condition. That condition, let me explain you first, then I will jump over here, right? That condition, basically this condition we are talking about, right? That condition which when the deadline is attached to the derrick leg of the hosting drum. This is the case 1. This is the case 2. Deadline is attached to the derrick leg opposite to the side of the fast line, right? And next, third case is the deadline is attached to the traveling block, right? I will give you the idea why, I will give you the derivation of each of these things, and why we are doing this thing. We are going to know this thing. This is called Derrick efficiency factor. We are also going to calculate this thing, right? So these are the three cases. So what are these cases? Let me discuss one by one. So in the, let's suppose the first case, they are saying that this deadline can attach anywhere. Either they are saying they are going to attach in this side, or they are going to this side, or any of these leg side, right? Or the the first condition is they are saying that the deadline is going to attach either on this side, means the hosting drum side of any of the leg, either C or D. It is up to you, right? Next thing, they are saying that the deadline is attached to the opposite to the hosting drum, means the leg A and leg B, any of these things. And the next case, the third case, is saying that if the deadline is going to attach in the traveling block. So the question is arised, why they are want to move the deadline position here, this position, anywhere. What is the logic behind it? I will let you know in just few minutes. So why they are wants to do this thing, right? Now in this case, in the right now in this table I am talking about, this table, right? In this table what we are going to learn about, we are right now we are dealing with the second case. Second case we are means when the dead line is attached to the opposite of the fast line, right? This case we are assuming A, B, C. So for this case this table is there, right? So now we need to understand, on a hosting system there are only three load is acting. That load could be the hook load, which is written over here, the hook load, right? This hook load, fast line load, and the dead line load. These are the three loads which is acting on the rig floor, right? Or you can say on the derrick. So that load could be, we know that the hook load is, total load is W, and the fast line load is nothing but the W by NE. We know this thing, and the dead line load is W by NE. So up to this thing, this condition, and this total load, we know that hook load is W, fast line load is W by NE, and the dead line load is NE. So W by NE. So these things we are already knowing this thing, right? So now what we need to understand. So now if I am talking about the hook load, right? If I am talking about the hook load is acting at the center, right? Just imagine that you have a wooden block of table, that table having a 4 leg, and you are sitting at the center. So if you are sitting at the center, all the leg will experiencing a same load, right? So if you have a W leg, then these W is distributed in this A, B, C, D. So that could be W by 4, W by 4, W by 4, W by 4 in each leg, right? No doubt about it. Up to this means that W by 4 each leg is going to experience. And if you sum of these W by 4 plus W by 4, you take the LCM 4, you will get W plus W plus W plus W. That could be 4W divided by 4W means W, right? You will get the W. This is how the things are there, right? Now the fast line, we talk about the fast line. Fast line is attached in between leg C and the D. So what is the fast line load? Fast line load, we have learned this thing, right, in a previous class. The fast line load FS, which is nothing but the W by NE. Now this is the total load acting in the fast line, and this total load is divided into these two legs C and D. So can I say Fs can be W by 2Ne? So now, so in the leg A they are not experiencing, that's why dash is there. Leg B they are not experiencing, that is why dash is there. So leg C and D is experiencing the fast line load, that's why W by 2. Means this total load is divided between the two legs only, right? I hope you people are understanding this concept. This is very important concept regarding the hosting system, right, and the load distribution. Once you are able to understand, there is nothing, the simple calculation is there, right? So now next thing what is very important is that when the deadline, let's talk about the deadline. Deadline is the load is only attached in the leg A. So what is deadline load? W by NE. So W by NE is the total load is experienced by only leg A, right? Total load is experienced, that's a W by NE is experienced by the only leg A, right? And these all legs are not experiencing W by NE, right? Now what we want to do this thing, we have to sum the all the load, right? So in the leg A, when we talk about, so there is a W by 4 and W by NE. These load is only acting for NE, and if you talk WN plus 4W, if you take a common of WN plus 4 divided by 4 NE multiply by W. So this derivation you will get. If you sum this thing, you will get this thing. If you sum this thing, you will get this thing. If you sum this thing, you will get this. Let me solve this for this case. Let me solve this thing. So the second case we are talking about leg C. Let's talk about the leg C. Leg C I am talking about W by 4 plus W by 2 and E. Simple LCM you have to take. Take the LCM for any. 4 will cancel out. W by NE will be here. At this point 2 will be there and NE will be 2W will be there. If you take the common, we will get the W, this value, multiply with the W, right? This value will get. Now hope this concept is very clear to everyone. Now the very important thing right now I am talking about, that important term is nothing. You need to understand that. Imagine which we want to identify that which leg is experiencing more load, right? So if you talk about this W hook load is common in every leg, so we don't have to talk about this load because this is similar in every cases. So only thing we need to have, we have is leg C and the D and the leg A, right? So if you observe carefully, this W by NE is distributed in these two legs, so this will experiencing lesser load comparative to the leg A, because whole the load of the dead line is experienced by the load A, leg A, and that load is this much, right? So what is the logic, what is the motive behind this? So now the logic is here, means if the leg A is experiencing a more load, then there is a chances of fall down of a leg is very high. In any case, any of these four legs fall down, the whole rig system is collapsed. So we have to introduce another term. That another term is called maximum equivalent Derrick load. Let me explain you again. That term is called maximum equivalent Derrick load, right? And that maximum equivalent Derrick load is nothing but the 4 times of maximum load on one leg, any leg, right? To ensure the safety and robust Derrick design under the worst case of the loading condition, that's why they are multiplying with the 4, right? So this value, this is 4, and this leg is experiencing this much of the value load. If you calculate, then FDE, maximum Derrick efficiency load, you are going to get it 4 by NE multiply with the W in case of a leg A, right? Remember this thing. Now the very important parameter is introduced, the parameter used to compare the different different drilling line arrangement is called Derrick efficiency factor, and Derrick efficiency factor is defined as actual Derrick load by the maximum Derrick load, right? Actual Derrick load by the maximum Derrick load. So what is the actual Derrick load? So actual Derrick load, if you remember that the FDE, so FD, actual Derrick load, just now we have calculated in the previous slide, yeah, FD, okay, so FD, right? So actual Derrick load FD is nothing but the hook load plus fast line load plus dead line load, right? If you solve this thing, you know this thing, what you are going to get 1 by NE plus NE by NE multiply with the W. In the previous derivation we have went through this thing, right? So this is the Derrick load, and the maximum Derrick load is this. So if you divide this thing to find the DEF 2, why I am writing 2, we are doing for the case 2, right? So in this case what we are going to get 1 by NE plus NE, 1 plus NE by NE, multiply with the W and further divide with the N by 4 N multiply with the W. This W NE will cancel out, and finally this value you are going to get. Now the important thing you need to remember that these factor indicate that the how efficiency of the Derrick structure is utilized, right? A value closer to 1 means better load distribution and the more efficient use for the drilling capacity, right? That is why we are doing this thing, right? This is how the things are, right? Now what we need to study, and so this is the case 2 we have derived. Now we want to derive this thing for case 1 also, right? So what the case 1 is saying that, okay, so these are the case after solving this thing, I think we will get this value, yeah, this value for the case 2, right? This value for the case 2 we have obtained this value. Now we want to solve this thing for case A 1 and case 3, right? So let's discuss the first case. The second case was dead line is attached to the Derrick leg opposite to the side of the fast line. So this was the case we are talking about. Dead line is attached to the opposite to the fast line. This is your fast line opposite to the any of the leg, right? Now let's discuss about the first case, right? The first case was they are saying that the dead line is attached to the Derrick leg of the hoisting drum side. So if you let me draw the small diagram for you people. So we are assuming that this is A, this is B, and this is C, and this is D, right? And here is the drum, hoisting drum, right? So they are saying that the dead line is attached. Earlier case dead line is attached over here. Now this case they are saying that dead line is attached to the Derrick leg of a hoisting drum side, right? Any of these leg. So let me do the load distribution for you people. So this is the small sketch. So what are the load we have? We have hook load, leg A. Let's suppose A, B, C, and let me do it clearly so that you can understand, because this is, yeah, so this is the table I want to draw, and once you are able to understand that, nothing to worry about it. 1 2 3 1 2 3 4, okay, leg A, B, C, and D, and the load are the fast line, hook load, fast line load. This is hook load, this is the FS, fast line, W by NE, and FD, FS, FF, it is FS is its dead line, W by N, right? These are the things are over here. So what I need to do, we just, so W will be hook load, that is everywhere same, no changes, right? In this case this is also fast line is there, right? So W by NE, W by 2NE, sorry, 2NE. Now only thing what we have done now, the earlier case fast line was there, sorry, dead line was the here. Now this dead line is attached any of the Derrick leg. Let's suppose I am assuming that I have attached this leg at C. So this yeah, at the C. In that case there will be, let me think, so this W by fast line is attached at over here, right? So now here it is dash, or either you can consider this place also, right? So we can clearly assume that the maximum load is acting on the C. So we need to sum up this thing. So leg C, we are assuming that, not assuming, this is clearly mentioned over here that their leg C is experiencing more load. W by 4, W by 2 NE, by W by N. You will get this value, right? Right, if you take the LCM, let me do it for, yeah, there is a space is there. So let me do the LCM. 4NE you will get 4 will cancel out, you will get W by NE. There will be the 2 will be there, 2W over here. Now this NN will cancel out, this 4 WE will be here, right? Now you take the common W, you will get the final value En over here plus sign, 4E will be there plus 2 and divided by 4Ne, right, multiply with the W. So this is the leg C is experiencing this much of load. This is the maximum load. Now if we want to calculate FD, maximum equivalent Derrick load, then we have to multiply with the 4 multiply with the maximum load. That maximum load is En plus 4E plus 2 divided by 4Ne multiply with the W, right? This 4 will cancel out. The maximum equivalent Derrick load will be En plus 4E plus 2 divided by Ne multiply with the W. Now let me remove other stuff, right? Now the noise. So we have obtained this value. So now we need to calculate the Derrick efficiency factor for case 2, right? Derrick efficiency factor for the case 2. So DF, Derrick efficiency factor for case 1, not for case 2, this is for case 1. So that is nothing but the actual Derrick load. The actual Derrick load was En plus E plus 1 divided by Ne multiply with the W divided by this load En 4E plus 2 divided by Ne multiply with the W. This W will cancel out this thing. So you will get Derrick efficiency factor for case 2 En plus E plus 1 divided by En plus 4E plus 2. So I hope this is clear to you. This is the case 1 I have done, right? So let's move to the another slides. Case 2 we have already discussed. We don't want to discuss over here because we have already discussed. Now we want to do this thing for the case 3, right? This is very interesting. Trust me, this is very interesting, right? You will learn something different, right? So let me draw the table for again. Let me do in the zigzag manner so that nothing to worry. A, B, C and D, right? Leg A, leg B, leg C. So hook load W by 4, W by 4, W by 4, W by 4. Then the fast line load will be same. Fast line, yeah, W by 2Ne plus W by 2Ne. The next case is saying that dead line is attached to the traveling block. Traveling block means at the center, right? So the W by A, the load fast line dead line is Fs is W by N will experience by the each leg. Are you getting my point or not? Because it is acting now at the center. So this could be W by N dash, not dash, W by N, W by 4N, 4N, W by 4N, right? So this is the load. Now we have to sum any of these load. So now we have to sum it. Now we can clearly see that these either in the C or D are experiencing a maximum load, either C or D. So these C and D are the same load they are experiencing. So now let's solve for leg C. We are assuming that in the leg C is not assuming, leg C experiencing maximum load, that is nothing but W by 4, W by 2 NE, W by N 4N, W by 4N, 4N, right. Let's take as LCM of these. If you take the LCM, you will get 4NE as a LCM. This 4 will cancel out, W by NE plus this 2W will be there, plus 4 will cancel out, W by W into E will be there, right? If I am correct, yeah, if I am correct, right. Let's me check over here. W by NE, in this case you take the common of W, you will get NE plus E plus 2, right, multiplication of W. Now this is the leg A. Now if we want to calculate the FD, maximum equivalent load, that which is 4 times of maximum load is NE plus E plus 2 divided by 4 NE multiply with the W. This 4 will cancel out. Let me erase at the top. So we will get something, we will get some value, and that value, in this case FDE, maximum equivalent load, is NE plus E plus 2 divided by NE multiply with the W, right. So this is the this load is maximum equivalent load in case C3, right. We need to calculate D Derrick efficiency factor for case 3. So in that case, so we know that actual Derrick load is nothing but En plus E plus 1 divided by Ne multiply with the W divided by Ne plus E plus 2 divided by Ne multiply with the W. This term will cancel out. You will get the final value of DEF3 is En plus E plus 1 divided by Ne plus E plus 2, right. This value you will obtain, yeah, this value. So this is all about the load distribution, right. In upcoming class we will try to solve some basic other concept, right. Thank you for this thank you all for watching my content and liking my